Now let us look at what exactly is short-term memory. So short-term memory, it is often called as working memory or context window. So short-term memory is the immediate live data the agent is processing right now. So short-term memory is the immediate live data the agent is processing right now. That is a short-term. As the name suggests, short-term memory. Short-term memory means it will be storing information for a very short while. So immediate live data which the agent is processing is the short-term memory. The immediate live data which the large language model is processing is the short-term memory. So short-term memory is also called as the working memory, context window. So whatever input prompt you are giving to an LLM, so the content of that input prompt or that input prompt itself is the short-term memory, because the input prompt you are giving to a large language model is the immediate live data which the LLM is processing right now. So that is the short-term memory. So it is also called as context window or the working memory. So short-term memory is volatile in nature. It means short-term memory is not stored. Like if the session ends or the context window fills up, the information is lost. Information is not stored. That's what short-term memory. When once the session ends or the context window fills up, the information is lost. And if you want to store that information, you have to move it to the long-term storage. You have to move it to the long-term storage. And once it is stored in the long-term storage, it will become non-volatile. It will stay there forever, because long-term storage is persistent memory. Long-term memory means the information will be there forever. Unless you delete that, it will be there. So non-volatile. So now it's very clear short-term memory. So if we talk about short-term memory includes the active context. So the input prompt you are giving, and that input prompt can contain the user query along with some system prompts, along with some context. So whatever we are feeding to the large language model, that is the active context. So short-term memory includes the active context, the now. So everything currently loaded into the model's prompt. So everything which is currently loaded into the model's prompt is the active context. So the current conversation. So the active context, it remembers the last 5 to 10 exchanges. So it does not repeat itself. So what we are doing is that, like, I am giving a query to the large language model, it is generating a response. Now the important information of that response, I am appending it in my next query. Like that I am doing. So in this way, I am maintaining an active context. But because of the limited context window size, after a point of time, I will be needing a long-term memory, so that if the context window overflows, that information I can store it in the long-term memory. Now, active context, it also makes use of the thread. So if you say he was great, the agent uses the short-term memory to know who he refers to. Because if I look at a statement like he was great, it is very ambiguous. So the large language model might hallucinate. So it will look the short-term memory to know who he refers to based on the sentence immediately preceding it. And from there, he will identify who the he is. So that is what active context is. So active context is basically whatever is there in the context window, like whatever is currently loaded into the model's prompt is the active context. And in active context, we maintain the current conversation, like we remember the 5 to 10 exchanges, and it also acts like a thread wherein it avoids the large language model from getting hallucinated. Short-term memory includes intermediate results, the chain of thought. So if we have a complex task, So we know that for a complex task, we have to break it into multiple steps. So we will get multi-step task. So for a complex task, we have to break it into multiple steps. So we will get a multi-step task. And if we make use of the short-term memory, we can make use of the outcome of every step. We can store the outcome of step one in the short-term memory so that step two can make use of it. Because we know that in a multi-step task, these steps, they depend on the previous steps. So in a multi-step task, work in progress data, like the outcomes of individual steps, that is a work in progress data, we can store it in the short-term memory. Also the raw data, we can store it in the short-term memory. Let us look at an example. If an agent is researching a company's stock price, if an agent is trying to research a company's stock price, then it will be storing the raw data in short-term memory before it synthesizes that data into the final summary for you. So like an agent is researching a company's stock price. So the raw data, the stock price, it is storing it in the short-term memory. And also for task tracking, it makes use of the short-term memory. So agent keeps track of subtasks. Like let us suppose the one of the step of a complex task was to search the news, and if it is finished, the state of it will be stored in the short-term memory. So short-term memory keeps track of which subtasks are finished and which are still pending. So that is the importance of short-term memory. So now it's very clear that short-term memory is used to store the intermediate data, the work in progress data, and also the raw data. So agentic AI systems, they can store their raw data in the short-term memory, which will be needing, which it will be needing to do some processing, and also the work in progress data, the task tracking, that data also it can store it in the short-term memory. So that is the intermediate results, which we can store it in the short-term memory. Short-term memory includes recent messages and system instructions. Short-term memory includes recent messages and system instructions. So short-term memory holds the system prompts. This is very important. And recent chat history. And with this, we will be able to achieve constant adherence, because system prompts, it also represents some important constraints. Like if you told the agent at the start of the session to only respond in bullet points, so that's a system prompt. Like system prompt is giving instruction to the large language model how to behave, giving instruction to the large language model how to behave. That is the system prompt. So if we are giving a system prompt to a large language model, like only respond in bullet points, so this system prompt, we can store it in the short-term memory. So a system prompt like only respond in bullet points, it sits in the short-term memory. And because of that, it will be the part of the context window, and every query we give to the large language model, this system prompt will always be there. And hence every response will adhere to this constraint, and the response will always be in bullet points. So all the subsequent responses will consider this system prompt, will be guided by the short-term memory, because now it's very clear to us that short-term memory is the active memory, the context window, like whatever input we are giving or whatever the prompt we are giving to the large language model. So the prompt in itself is the short-term memory. So the context window is the short-term memory. And we know that in the short-term memory, we store the system instructions and also the recent messages. Short-term memory also includes technical constraints, and it is the bucket analogy. So let us understand the bucket analogy. So You have to imagine short-term memory as a bucket of fixed size. So here we have a bucket of fixed size, as you can see. Now this bucket of fixed size is acting like a context window, because in this bucket we can fill, and if it is a context window, we can fill the messages. So as we keep on pouring, overflow might occur. So the overflow is when, like as you pour in new messages, the oldest message at the bottom get pushed out. So now very important, we are discussing the overflow scenario of a context window. So we know that the size of the context window is fixed, and if we keep on adding new messages, after a point of time, it will overflow. And when it will overflow, the oldest message, the oldest message will be flushed out of the context window. And this is the reason why the agentic AI systems, they forget the very first thing you said in a very long conversation. So the very first thing you said in a very long conversation, after a point of time, it will forget it. Because of the limited context window size, new messages will keep on pouring with subsequent interactions, conversations, and the oldest messages, they will get flushed out. And the agent will start forgetting those old information, oldest messages. So this is a very important conversation, like the insight we got, the overflow of the context window. So new messages push out the oldest one, and because of that, agent forgets the start of a long chat. And how we can prevent it? The management techniques, let us understand that. Management techniques, summarization. So in summarization, what we do is that, so two techniques are there. One is the summarization, one is the sliding window. So both the techniques we'll discuss. So in summarization, what we will do is that the old message which is about to get flushed out, we will summarize few of those old messages. So the idea is that we will condense the old parts. So here, let us suppose M1, M2, M3, these are like very old messages which are about to get flushed out. So we will combine them, summarize it, and condense them into a single block and add it on top of the bucket. Because of that, what we are doing is that when the overflow will occur, instead of just flushing out the previous, like the oldest messages, we are taking the oldest messages, condensing it, summarizing it, and once again putting it on top of the bucket. So a cycle we are creating. And this is a very powerful technique. Because of summarization, at least it will not forget everything. It might forget something, but not everything. And we will be able to preserve the context. So now we discussed a very interesting technique to, like, see, context window overflow is very common because context window is fixed size, and in a long conversation, after a while, overflow will definitely occur. And when the overflow will occur, how to manage it? Because we know that when the overflow occurs, the oldest messages, it gets flushed out. Because of that, the agentic AI system, it starts forgetting the start of a long chat. And how we can avoid it is summarization. So the oldest messages which are about to get flushed out, if we can just condense them, we can summarize them and put it back on top of the bucket. So that is one very interesting technique. Second technique is the sliding window. So in sliding window, what we are doing is that messages, we are storing it. All the messages, we are storing it in short-term memory, and we have a sliding window. So whatever is important, like for a particular interaction, whatever messages are important, only that will be the part of the window. So we will be moving the frames, focusing on the recent items. So that's the sliding window. So we can manage the context window overflow by summarization and by sliding window. Now let us understand the importance of short-term memory, like why short-term memory matters, reactive versus logical. So let us understand the importance of short-term memory in agentic AI systems. See, without short-term memory, agent cannot reason. So if there is no short-term memory, the agentic AI system will treat every single sentence as an isolated command. Like if there is no short-term memory is there, every sentence you give it, it will be treating it like an isolated command, making it impossible to have a coherent back and forth discussion or complete a plan. So if there is no short-term memory, the agent will treat every sentence as an isolated command, impossible to have coherent discussion or complete plan. It will be a reactive system. And what is a reactive system is that whatever you are giving it now, command or the input, it will just process it. It will not, it does not have access to the past interactions. It does not remember anything. So it is just reacting to whatever you are giving input. So that's the reactive. But if we make use of the short-term memory, so if agentic AI system is making use of the short-term memory, then what will happen is the discussion will be coherent and back and forth. So short-term memory, it enables reasoning because short-term memory is the context window. In that context window, we are storing some responses of like previous 10 chats. If we are storing the responses, so the agent will remember the past interactions also. So next time it is generating a response, it will consider past interactions as well. It will enable reasoning. Like in a multi-step task, it will be remembering the responses of the previous steps, and while processing a current step, it will make use of those previous responses as well. It short-term memory enables reasoning, coherent back and forth discussion, and completing plans. So with short-term memory, our agentic AI system will become logical and reasoning. So this is the importance of short-term memory. So if we just summarize the short-term memory's role, if we just summarize the short-term memory's role in agentic AI systems, so short-term memory acts like a focus. So short-term memory defines what the agent is paying attention to right now, because short-term memory is the active context window. So whatever is there in that context window is been considered by the large language model. So it is like a focus. So short-term memory, the context window is like a focus, because whatever is there in it will be considered by the large language model. Speed. Now short-term memory is like active and live data. So accessing it is very fast. So accessing the short-term memory is instantaneous because it's a part of active prompt, and there is a limit is there to short-term memory. Short-term memory is limited because the context window is limited. So short-term memory is strictly limited by the model's token count. Like for GPT-4, it is 128K tokens. So short-term memory is strictly limited by the model's token count, like 128K tokens for GPT-4.